Well, greetings out there to all you tube junkies in YouTube land. I hope you're ready for part 3 of our epic video series covering the hand building of a vintage Supro 6422 RT amplifier. In this chapter, we're going to discuss how to properly select the transformers for this build. This is something I get asked a lot about, so hopefully this will help you. We'll also construct a parts sheet to allow us to order all our parts in a systematic fashion. And finally, we'll discuss the cost for the parts so far. If all this has you quivering in expectation, then please grab your popcorn, sit back, and get ready for part 3. Hey Jack, are you ready to help me with this video? Are you watching lizards out there on the porch? Okay, wag your tail if you're really anxious to help me. Ah, what a good boy. Okay, now we're going to discuss how to select the transformers for our project. Now this is sort of an elusive art, but it doesn't need to be, because there's two ways to do it. One is very difficult and one is very easy, and I'll try to explain both. Number one, you have to be concerned with what are the demands of the filament circuit, the 5-volt AC output. Well, if we're going to use a 5Y3, you look it up in the tube handbook or on the internet, and it's going to say that the filament requires 2 amps. Okay, that's simple enough. The 6.3 volt AC circuit's a little more difficult. You add up the requirements of each of the tubes. 12AT7 is going to want 300 milliamps. 3 12AX7s are going to want 300 each for 900. Okay, and then remember I was going to use either a 6V6 or a 6L6, so I'm going to have 2 totals here. If I use the 6V6, my total will be 1.65 amps that will be required for the 6-volt filament circuit. If I use the 6L6, it's going to jump up to 2.1 amps for this circuit. So let's write down over here 2.1 amps are going to be required for the 6.3 volt AC circuit if I use the 6L6. Now the third one's a little more challenging, and that's the high voltage. Now calculating the high voltage circuit current demands is a little more challenging, but it's almost all used by the power tubes, the output tubes. So let's look at 6V6, and this is the plate current. Okay, a normal plate current on a 6V6 is going to be what, around 30, maybe up to 35 milliamps. On a 6L6, maybe 40 to 45 milliamps. 12AX7s use almost no plate current. All 3 of them are only going to account for 7.2 milliamps. And the 12AT7, which is a relative current hog for a 12A type of tube, is 20 milliamps. So it looks like, worst case scenario, I use the 6L6. I'm at around 40 milliamps, 7.2 here and 20. That's what, 67.2. Okay, so I'm going to write down here approximately 70 milliamps for my high voltage current requirement. And now let's determine the high voltage requirements for a transformer. Now let's look at a very common type of power transformer, the 325/0-325 version. It has to be center tapped if you're going to use a tube rectifier or diode rectifiers. And in this case, it's 320 volts between the center tap and either of the output legs, which means a total of 650 volts AC. However, because we're going to convert it into direct current, there is a formula to calculate what the direct current output would be of a 650 volt AC transformer. You simply divide by the square root of 2, which is 1.414. You plug in the 650, divide by 1.414, you're going to get absolute maximum ideal would be 459 volts DC. Now this 459 volt DC output is ideal and unobtainable because during the rectification process, especially using a 5Y3, you're going to have a lot of loss. Okay, you're going to lose probably 75 or 80 of these volts to the rectification process. So that's going to bring it down to around 380 to 390 volts DC. My Supro schematic says that 360 is about right. So I'm going to be a little above what the Supro schematic recommends, but it's a whole lot easier to be a little above than a little below. If I came in at, say, 340 by using a 300 transformer, there's no way to boost up to the 360 I need. But if I come in at like 385 with this transformer, I think you can see there are ways, if necessary, I don't think they will be necessary, but ways to bring the voltage down a little bit to suit the circuit. So I'm going to go with the 325 transformer. And as we saw from our initial tally here, therefore I'm going to need the, like I said, 325 high voltage with capable of it around 70 milliamps or a little more would be nice. Around 2 amps capability for the 6 volt filament circuit and 2 amps capability for the 5 volt filament circuit. So armed with that knowledge, I'm going to go looking on the Triode Electronics website and at classic tone transformers, and I came up with this one that's looked pretty good. Remember, I needed for my 6.3 volt I needed 2.1 amps worst case with the 6L6. Well, this has 2 amps, 5 volt filaments. I only needed 2 amps. This has 3, so I guess I could use a 5U4 if I wanted to in my circuit. And up here we've got the 650 volt center tap, so this is a 325 transformer, and remember I needed around 70 milliamps. Well, this has it. Now a lot of people suggest that you go like 50% over whatever you need. So if you need down here, you need 2 amps for your 6.3 volt filament circuit, then you should get 3. Okay, if you need 70 milliamps here, then you should get at least 100 to 120 milliamp current capability. I'm going to tell you right now, I don't do that, and here's why. First of all, this transformer is built with probably at least 20% leeway over these values. Okay, you know darn well they're not going to sell a transformer that is going to work fine at 2 amps and then burn up at 2.1. Okay, it's just not going to happen. Also, I can tell you that the manufacturers don't do that. They will use the same parameters I used, and their assumption is the same as mine, is that there is leeway built into the transformer and that you can do what I did, and that is tailor not to 150% of your need, but to 100% of your need. Okay, we just went through a whole lot of work to figure out the transformer. Now I'm going to tell you the easiest way in the world to do it. Now this method is one that I've shared with viewers, but let's go ahead and just include it in the video so everybody can hear it. And that is, based on whatever the tube complement is in your amp that you're going to build, simply find an existing, well-known, popular amp that has a similar tube complement and use that power transformer. Let's take a look at the tube complement of the Princeton Reverb, a very popular, successful amp, which is certainly not known for power transformer failures. Let's look at the tube complement here, and we have 1 12AX7, 2, 3 12AX7s, just the same as our Supro circuit. We have a 12AT7 to drive the reverb tank, exactly the same. Now our Supro is going to have 1 6V6. The Princeton Reverb has 2. If we put a 6L6 into the Supro, its current demands and filament demands are about the same as 2 6V6s. So it looks to me like this tube complement exactly matches the one that we need for our Supro. So instead of going through and adding up current demands and everything else, I think what we need to look at is a power transformer for a Princeton Reverb and use it for our Supro build. And by coincidence, it's exactly the same transformer that I came up with doing it the long and difficult way. If you look right down here, this transformer is recommended for both the Princeton and the Princeton Reverb. So, two ways to get to the same outcome. I think this transformer is going to work just fine, and I'm going to order one of them. Also, it should be noticed on this spec sheet that this transformer is rated at a 15 watt output, which is certainly generous for one 6v6 and definitely some comfort zone when you have a single-ended 6L6 amp. So the heat dissipation capability of the transformer is fine. Also, it's kind of interesting, look up here. Measured B+ voltages at 70 milliamps using a 5Y3 rectifier. Remember, I estimated, what, 380 to 390? 383 volts DC. So this is ideal for the Supro circuit. Okay, let's talk now about output transformer selection. And generally with single-ended amps that use 6v6s, all you need is a 5 watt output transformer. But since I want to be able to use a 6L6, and it would be nice if you could drive that 6v6 a little hard, I want to go over the 5 watt and go to an upgraded single-ended output transformer that is capable of handling 15 watts of output, as you see down here at the bottom, instead of the normal 5. Also, this is nice. You have a choice of either a 5K ohm input or an 8K ohm input. This would be good for the 6V6. And if, say I wanted to change over to a 6BQ5 output tube, then you could go up here to the 8K input. Over here, I'll have outputs that are capable of handling speakers of 4 ohm, 8 ohm, and 16 ohms. 15 watts across the board. Now, this transformer is going to cost a little more, but it's going to give me, I think, much better tone and a really nice ability to interchange tubes if I choose. So it's going to provide some flexibility. And last but not least is the Reverb driver transformer. A 125A20B fender part. This is very standard. I'll just go to the Triode page and look up their equivalent classic tone transformer, which has these exact specifications. 25,000 ohms of impedance to match the 12AT7, 8 ohms of output impedance to match the tank. Rusty's new contract requires that he receive one cookie for every scene that he appears in. So here, we'll set it down for him. There you go, Rusty. Now you've taken payment. Are you ready to help me with a video? It doesn't look like it. Rusty, it looks like you finished devouring your bonus. So now, by your contract, you're going to have to help me with this video. Are you ready? Are we going to get to work? This isn't looking good. Now let's look at an effective way to create a parts list so that we can order everything we need effectively one time rather than having to have a bunch of follow-up orders. How I do this is very simple. I just download a copy of the schematic and then just start on the left side and move to the right in some systematic pattern, and write down the values of all of the electrical components that I encounter. Here I'm going to write down 100K resistors, and I'll put 2 hash marks by it because I need 2 of them. Over here I'll write down 35 microfarad at 50 volts for capacitor. I create a list of resistors and a list of capacitors with the working voltages for me to order. In this circuit, I'm going to use all 1 watt resistors minimum, unless the schematic specifies a higher wattage, like in this case 330. It specifies 2 watts. It's probably a good idea to make a little check mark by each of the resistors when you write it down, and then go back over and make sure that you've included all of them. Now that's for the electrical components, the resistors and capacitors. Next, I'll go through and make a list of all the mechanical parts. Remember, I'm going to eliminate this high treble input, so I'm only going to need 2 self-grounding input jacks. Come over here, I need a 9-pin mini tube bass with shield. And I write this down on a sheet, and then I do hash marks. I'm going to need 1, 2, 3, 4 of the mini tube basses. I'm going to need an octal bass for the 5Y3 and an octal bass for the 6V6. And continue. You also need to get your toggle switch and just the mechanical parts that you're going to need for this. Fuse holder, pilot light, and things of that sort. And then, as I've learned the hard way, there are certain things that you just tend to forget. So let's go over a list of things that are easily forgotten, or maybe not so evident on the schematic. Of course, you're going to need your tubes and your speaker. Here's an easy one to forget. You also need knobs for those 5 potentiometers. In this case, with a reverb tank, I have to have shielded cables for the reverb tank. Sometimes you'll put down fuse holder and forget to see if you have the right fuses. Pilot light might not even be on the schematic or not evident, but you're going to need one. Terminal strips, when we do point-to-point wiring, I'm going to get a bunch. I'll get 10 by 10, so there's be 100 little lugs for me to use. Power cord, 3-wire chassis grounding power cord with the strain relief. You're going to need a plug for your speaker, and you're going to have a couple ungrounding jacks for your speaker output. These are the female jacks. I'm going to have one for 4 ohm and one for 8 ohm output. That's not on the schematic, so I'm going to have to remember to order those. I'm going to need 4 RCA female jacks. I'm going to need 2 for the reverb cables to connect to the chassis, and I'm going to need 2 for the foot switches to connect. I'll need a handle for the cabinet. Now, I am not designing my cabinet yet, so the color's a little up in the air, but sooner or later you're going to have to buy that handle. I'm also on this one, since I'm going to incorporate the foot switch, I'm going to get the Fender style 2-button foot switch. They're on eBay. Also, you can order them from the same places that you order your components normally. And finally, if I put in the cathode bias selection for 6V6 to 6L6, I'm going to need the single pole double throw toggle switch. Now, God only knows I've probably still forgotten a few things, so don't feel bad. It happens all the time. I have to send in another order. The downside of that is you have to pay like $6 or $7 freight for an item that might only cost $2. So it's really best to be careful when you first place your order, so they can put it all in one box. I'm asked repeatedly where I get my parts. I get my transformers from Triode Electronics. They have those classic tone transformers that are available at, I think, very reasonable prices, and they work great. And I get all of my electronic components from Antique Electronic Supply in Tempe, Arizona. I'm not on their payroll, and this isn't a paid advertisement, okay? It's just simply they are the people that I have the best luck with. Okay, and I've been asked several times for an estimate of what this project's going to cost, so I'm going to keep a running total, and I'll let you know. But let's just cover it real quickly where we stand right now. I have the tubes, but I'm going to estimate that there are 6 vintage tubes, and I'm using really high quality, tested, very well vintage tubes. I'm going to estimate, say, $10 a piece, so that'd be $60 if I had to buy them. The vintage speaker, I'm going to use a 1965, 1966 Jensen original 12-inch speaker. I've seen them for sale on eBay, usually from like $100 to $125. I'll put it down at $100. The transformers, for the 3 transformers, the total was $113.31. The miscellaneous components, which is everything, all the mechanical parts, all the ones on my easily forgotten list, added up to about $175. I bought a piece of metal for the chassis already, and the portion of that sheet that I'm going to use will be worth about $5. So the subtotal right here is $453.31. Now, I have an idea that's way higher than you were expecting, and we're not finished yet. We're still going to have to build a cabinet and cover it, and there's going to be some other things that have been forgotten. So I'm thinking we're probably going to get up somewhere around $600 just on the parts to build this amp. Then if you use a rather traditional basis for your labor costs, a lot of people simply double the parts cost, okay, which is actually probably around minimum wage when it gets down to it. But if we end up with around $600 here for parts, that means that on this single-ended little Supro amp, if somebody asked you what you'd sell it for, and you said $1,200, I think you'd be completely within your rights. But from personal experience, I think a whole lot of people are just going to roll their eyes and think that you are an absolute thief for expecting that much money for a homemade amp. So besides all the technical pointers that we take away from this series, I just want you to realize what's going into these things, why boutique amps cost so much. If I had gone in for mercury magnetic transformers, this would probably be $250. If I had gone in for oil and paper capacitors and other real ritzy parts, this could have been $300. You know, the sky's the limit. I could have spent $250 on an Alnico speaker. This could easily have been $1,000 or more. Double it, it's $2,000. Who wants to pay $2,000 for a hand-built amp? Hopefully, someone does. But in my experience, they're few and far between. Now granted, most of us, myself included, don't really build amps to sell. They build them to keep. But from time to time, you might decide that you do want to sell one. And I think you'll see that considering the price involved in the construction, unless you're extraordinarily lucky, you're going to find out that this is more a labor of love than it is a good economic venture. So on that happy note, let's bring an end to this second chapter in our Supro saga. I really appreciate the time you've spent watching and hope you stay tuned. Next, we're going to sit down and design a cabinet and chassis for this that everything will fit in, and then the talking ends, thank heavens, and the building begins. So I hope to see you in the near future. Thanks for watching.